Hello and welcome to this MEI M1 revision video where we're looking at force as a vector through looking at January 2011 question 2. So this is the whole question, it's 6 marks. We're shown a diagram where we have two forces acting at the point A. So we have a 10 Newton force horizontally in the I direction, and then we have an 8 Newton force up at an angle to the left hand side. We're told the resultant of these two forces is F newtons, and we're also given the unit vectors I and J as part of the diagram. So part 1 asks us to find the resultant force F in terms of I and J, given our answers to 3SF, 3 marks, and then for the second part we have to calculate the magnitude of F and the angle that F makes with the upward vertical. So let's have a look at the first of those two parts. So we've got to find F in terms of I and J. So let's resolve in the two directions individually. So if we resolve in the I direction to start off with, taking the right as positive, so 10 is in the I direction positive, and then we have 8 newtons, 8 cos 50 would be the component horizontally, but 8 cos 50 would be acting in the opposite direction, so that would be negative. So 10 minus 8 cos 50 is the resultant force in the I direction, and if you work that out, 4.8576. And try and keep that value in your calculator, and then if we do the J direction, the 10 Newton force doesn't have a component vertically because it's all horizontal, so we're just looking at the 8 Newton force. That will be 8 sine 50 vertically upwards, so it's positive because it's in the positive J direction, and so that works out to be 6.128, and keep that value in your calculator as well. So the resultant force, round into 3SF, will be 4.86 in the I direction plus 6.13 in the J direction. Moving on to the second part, we have to calculate the magnitude of F and the angle that it makes with the upward vertical. So remembering our values from the previous part of the question, horizontally it was 4.8576 and vertically it was 6.1283, and this is our force F. The magnitude of a force is the size of it, so we can do Pythagoras theorem here. So the magnitude of the force F, we would have to square each of these two values, the horizontal and the vertical components, and once we've squared them, as with Pythagoras always, take the square root, and that works out to be 7.820, and so to 3SF that will be 7.82. And that's in newtons. Now the direction with the upward vertical, this is the angle that we want, if we call that theta. That would be the same using alternate angles as this angle here. And so we can say that tan theta is opposite over adjacent, 4.85, again using the full values, over 6.128. So work out this value and then do inverse tan of that value. That tells us that theta is 38.402, and so if we round that off to 3SF, it's 38.4 degrees with the vertical. Okay, let's go through now and have a look at how the marks are allocated on this question. So in part 1, you got a method mark for resolving in at least one direction. You got an accuracy mark for getting either of them correct, and then a final accuracy mark which has to be the correct answer only, and it has to be rounded to 3SF to get that mark because it's given that that's how they want it in the question. So that's the 3 marks for part 1. For part 2, we get an independent mark here, a B1, and that's a follow through mark. So following through your values from part 1, carrying out Pythagoras, that gets you the first mark. Working out the correct values and using the trig ratio gets you the method mark, and then a final follow through mark here again, following through your values to get the correct angle for your values from the previous part of the question. So that's the end of that question. If you'd like to look at any of the other videos, go to our website www.furthermaths.org.uk.